Students, today we'll discuss about another physics paper, JEE Mains Physics 2014. So let us discuss all those questions one by one. Okay. Students, let us solve the next question. Question number 11. 3 rods of copper, brass and steel. So the 3 materials are welded together to form a Y-shaped structure. Area of cross section of each rod is 4 centimeter square. So area cross section is 4 centimeter square. The structure is Y. End of copper rod is maintained at 100 degrees centigrade. Suppose this is copper and maintained at 100 degrees centigrade, copper. Whereas the ends of brass and steel, suppose this is brass and this is steel. I'll draw it afterwards properly, but just for the timing, let us have this. This is maintained at 0 and this is maintained at 0. Lengths of copper, brass and steel are copper 46, brass is 13, this is 12. Okay, I'll draw it properly afterwards. Let us just see the question. The rods are thermally insulated from surroundings, so no heat can escape or enter the system. The rods are thermally. Thermal conductivities of copper, brass and steel are given. K for copper, K for brass, K for steel. This is given as 0.92, this is given as 0.26. I think it is 26 or something like that. 0.26 and this is 0.12. Okay. Next is the rate of heat flow through copper rod is, this is the question. So let us draw the diagram and solve. You have to only find the rate of heat flow. That's all you have to find, rate of heat flow. So let us solve this question. Draw a proper diagram. It's given that there is a, this is the situation. This is copper and is maintained as 100 degrees centigrade. This is suppose brass and maintained at 0 degrees centigrade. This is also maintained at 0 degrees centigrade. This is steel. This length is 46 and steel length is 46, and that brass is the 13 centimeter and this is 12 centimeter in length. These are in centimeter. Okay, all the units are given in system. So and the Kb of copper, Kcu is the thermal conductivity of copper is 0.92, the brass is 0.26 and the steel is 0.12. These are the data given to us. The rate of heat flow. To find the rate of heat flow, let us say that the junction is having a temperature T which is not given to us. So first of all, we have to find the temperature of the junction and then we'll find the rate of heat flow. Rate of heat flow is just like the electric current. So it is the heat current, and as we know the formula for electric current, V equals to IR. So I equals to V by R. Similarly, for this we have a formula that the quantity of heat flowing per second is equal to some constant K, and A area of this, and d theta, that is dt, temperature gradient dt upon dx. Okay, so this is the heat current or rate of flow of heat. So this is I call h. If I call this as h, then this is k a dt over dx. This is temperature difference over the length. I have this length dx. The temperature difference is supposed between these 2 points is dt, then dt over dx. Now if I apply that concept to here, this point and this point, like this, these 2 points, the difference in temperature here 100 minus t, obviously it will flow from body at high temperature to body at low temperature. So current, the heat current will be in this direction, there is no doubt about that. So incoming heat, incoming current is outgoing current, it's just like Kirchhoff's current law. So this dt over dx residence 100 minus t I can write over for this, and this dx is nothing but this length. This length I'll call it just L1. Here I'll call this as L1. I'll call this length as L2 and this length as L3. Okay, this I'll call as K1. This I call K2 and this I call K3 for simplification. So 1, 2, 3. So so this is the thing. Now because of the potential difference, current flows. Because of the temperature difference, the heat flows. The concept is basically the same. Now I have to write the equation for heat. The incoming current, suppose the heat coming in is heat going out. The rate of this current V by R. If I look at this, you can see also that this I can manage to write like this. This divided by dx over ka, dx over ka. So this is just like the playing the role of potential difference, and this whole thing plays the roles of resistance in heat flow. So this is just like the formula. So let us say that heat flowing in is h, going out there is h2. For this side is, sorry, this is h1 I will call, because I consider this as 1 and I will consider this as 2. Okay, so this heat that is coming in is h, going out in this side is h1 and this side is h2. Okay, so from principle of energy flow, I can write that h is equal to h1 plus h2. Okay, now if I have h1 plus h2, then okay, now h1 plus h2, this is h, I'll write this. That means the temperature difference for this section is 100 minus t, 100 minus t divided by this value, the difference in the length between those two temperatures, that is 46, that is L1. I'll write this first, L1 over K1 A, because area cross section is same, and that equals to, for this part h1 I'll write t minus 0 divided by the length L2 divided by K2A, this will write here, plus t minus 0 again, t minus 0 divided by the length L3 divided by K3 and A over there. Okay, this is the question. Now we have to solve this. Let us use another phrase for this, and the paper I'll use. Now I will rearrange and keep K1A to the top of the expression. So this is K1A times, because I could have written directly this also, K1A dt by dx, that's much easier. But just to have a sense how this electric current and the heat current plays the role, I have just made this expression in terms of this. So this is called the resistance for the heat flow. Otherwise, I could have directly written this. So I have K1A 100 minus T divided by L1 that equals to K2A T minus 0 divided by L2 plus K3A T minus 0 divided by L3. So basically we have to solve this equation because everything is given else the T value. So from here you will get T, then also we'll find afterwards we'll take the help of that to get the expression for the heat flow. Now now I will cancel whichever is common, that is area of cross section, the Q is same. I'll cancel it out and plug in the value of K1 and L1 and K2, L2 and all. Then what will get that? K1 over L1. I have already made the list K1, K2, K3 and L1, L2, L3. I'll just put it here, okay? K1 is 0.92 divided by L1 is how much? 46 into 100 minus T. This gives you K2 is how much? It is 0.26 divided by this length is 13, okay? T minus 0 plus this is 0.12 divided by 12 and this is T minus 0. So 46 to is 92, 1892. This is 13 to is 26, 12 will cancel. So this is 0.02, okay? This is 0.02 into 100 minus T, that equals to, this is 2 and 0.02 again T plus this is this is 1 by 100 is 0.01 into T. So from here it is 0.2 by 100. So 2 by 100 here, 1 by 100 here, that 100 I will cancel out. So it is just like 2, okay? So 200 minus 2T equals to 2T plus T. So it is 4, 2 goes to that side, it is 2, 2, 4, 5. So it is 5T equals to 200. So T becomes 40 degrees centigrade. So that means the what we are getting now here is that the junction is having temperature 40 degrees centigrade. So once you get the junction as 40 degrees centigrade, now the question is to find the rate of flow of heat through the copper rod is copper rod. Copper rod is which one? This is the copper rod. Rate of flow of heat through this, how much heat is flowing. You can also find H1 or H2, but the question is to find only H, so it will write for H. The value of H you have to find out. So let us find out that H. But as I told you, the expression for H, that is why I told you this at the beginning. This is important. The H is this. I write that expression in the next page here and C. So this is the temperature of the junction. Now I will find the value of H. To find H through copper, the formula for H is K A and dt over dx, the temperature gradient. This factor is called temperature gradient. Now this is K for copper, I'll write, because I want for copper. And copper K value is given as 0.92. So this is 0.92 into area of cross section is 4 centimeter square. And the question is given 4 centimeter square. You can see here it's 4 centimeter square. So I'll put 4. I'll keep centimeter square. No problem with that. And dt, the temperature difference is now 100 minus 40 over dx. The length is 46. This is centimeter, this is centimeter square, this is 0.92. That is also in integers system, so no problem with that. If I solve this, I'll get this 2 is 92, 46 2s are 92, so this is 0.02, that is 2 by 100. So it is 2 by 100 into 4 into this is 60. I'll cut one this, and this is 6 4 the 24 to the 48. This is 48 divided by 10. So this is 4.8. If I see the option, and obviously this is calorie per second, because earlier this was in calorie, so I'll keep it in calorie per second. If I see the options, it's 4.8 calorie per second. So this is the right answer to this question. 4.8 calorie per second. Okay, thank you.